Hello, students. Welcome back for our next part in this topic, erosion and deposition. If you recall, last time we were talking about the agents of erosion, and there are no secret agents of erosion. We listed them yesterday, and I asked you yesterday to stay tuned for today, at which time we are going to start discussing right now running water as an agent of erosion. So this is a pretty big agent of erosion, so let's get right into it. There are three different forms of erosion when it comes to running water. Now, before we even get into these, let's just get one thing clear. Running water does not mean it's in a race. Running, the word running there simply means flowing downhill. Water that's flowing downhill is called running water. Okay, so it's not running in a race, it's just flowing downhill. As opposed to standing water, like in a puddle, pond, or a lake, that is not flowing downhill. So running water involves water flowing downhill, and there are three forms of erosion. First one is called runoff. Runoff is the flow of water over the land's surface. Seems pretty straightforward, I would say. If you think about runoff and you've ever looked outside the window or been outside when there is a really nasty rainstorm, then you have seen runoff. I'm sure you've seen runoff right in your own yard. Runoff is what carries debris from one end of your yard to your other. If your yard is on any type of a hill, could even be flowing down your driveway if your driveway is a hill. But runoff is the flow of water over the land surface. And there are some factors that can affect runoff. And I want you to really pay attention about these because we're going to be doing a lab activity dealing with running water and our stream tables that are set up in the back of the lab. That's right. Those things that I'm constructing back there are our stream tables that we will get to on lab day. So what are some of the factors that can affect runoff? Number one, or in our notes, letter A, the rainfall amount, how much it rains. You tell me. What do you think is going to produce more runoff? A little drizzle or torrential downpour? Yeah, torrential downpour. The greater the volume of rain, the more it's going to flow over the surface. Number two, the shape or the slope of the land. What do you think will experience greater runoff? A very shallow slope, a slope that's almost flat, or one that is almost inclined as much as a cliffside, a steep slope. What do you think is going to cause greater runoff? Probably the steep slope. Think of it in terms of sledding down a hill in the wintertime. On which hill are you going to travel faster? A more gradual slope or a steep slope? Well, you're going to go faster on a steep slope, and guess what? So will water as it's carried by gravity downhill. Here's another factor that can affect runoff, the plant growth and density. We actually saw this alluded to in one of the videos from yesterday. But if you've got a hillside that is just soil and another hillside that has grass growing on it, which hill do you think is going to experience more erosion from the runoff of water? Probably the one that's just soil. Why? Well, because the grass or other vegetation is going to be holding the soil in place with its roots. So think about that for our lab activity on Thursday. But regardless of these factors, runoff happens. We see evidence of it throughout the township we live in. And so there are different formations that can occur from the runoff of water, starting with what are called rills. Rills are described as tiny grooves in the ground. I like to think of being in a car in a rainstorm. Think of yourself being in a car while it's raining, and you're a passenger in the back seat looking at the window. What do you notice as the raindrops hit the window? Do you ever notice how the raindrops are kind of blown by the wind and travel from front to back? And sometimes the raindrops merge together and form a bigger raindrop. I remember as a kid, I used to watch the window and watch the raindrops flow on the window and merge together and then merge together again and see how big a raindrop could form as they're being blown by the wind, traveling forward on the highway. Well, think of those raindrops on a flat surface of the ground, and they are flowing over the surface in runoff. Well, those raindrops, as they merge together, if they are being pulled down by gravity, they're going to flow perhaps faster and faster, depending upon those factors we just mentioned. As they do, they're going to carry little particles with them, sediments, particles. And as they carry the particles downhill, they're going to be eroding those particles. Yes, depositing them on the bottom of the slope, but eroding them upstream, creating what we call rills. Now, if those rills continue to grow in size and those rills become deeper and deeper, they could develop into what are called gullies. Gullies, very simply, are wide, deep rills. So here in this picture here, we've got a rill forming, even though there's grass growing, and that rill over time can grow larger and larger at forming a gully. Now, this dotted line in the diagram is representing what's called the water table. It's a gully as long as that opening is above the water table. But as soon as that gully digs down or erodes deeper than the water table, then our next thing forms, which is called a stream. We may have different terms for them. A creek is a smaller stream. A river, which we'll get to, is a larger stream. But streams are the flow of water through a small valley, which is a deep gully that has cut deep enough to exist below the water table. In other words, a stream is a gully filled with water. In fact, gullies can become streams when it rains real hard because the gullies can fill up with water. But typically, in order to be technically considered a gully, after it stops raining, a gully will dry out, a stream will continue to flow. So streams, generally speaking, like those raindrops on a windshield that I was just talking about earlier, streams typically form from gullies joining together to form deeper gullies, which dig deep enough to be under the water table so that they are filled with water all the time. Now, I've mentioned streams after a rainstorm a number of times already. And imagine a stream. In fact, we have one right outside the classroom, the Pequest River here. If you look at it after a rainstorm, it gets pretty muddy. And the reason for that is what's called stream load. Stream load describes the particles that are carried by stream water. Now, on a normal sunny day, if it hasn't rained for a while, you look out the window here at the Pequest River, and the water is pretty clear. Not a lot of sediment being carried down. But after a rainstorm, All of those particles are being eroded from fields by rills, gullies, emptying into streams, and all that sediment, all those particles are carried downstream, and we call it stream load. Stream load obviously is something that increases after rainstorms when there is typically more erosion. Now, the Pequest River, which is really a stream, empties into a larger body of water, the Delaware River, which is a true river. Rivers are the flow of water through a valley formed by streams joining together. So the Delaware River here where we live is a major river system because there are lots of streams that empty into the Delaware River. There are bigger rivers, absolutely. The longest river system in North America is the Mississippi River system. In fact, I think is it the Missouri Mississippi River technically? But some rivers have hundreds and thousands of other rivers flowing into them, and those other rivers are called tributaries. Tributaries are rivers that flow into a major river. So the Delaware River actually has tributaries, which include the Lehigh River that empties into the Delaware near Easton. It also includes another tributary of the Delaware would be the Schuylkill River that empties into the Delaware near Philadelphia. But the Delaware River itself empties into the Delaware Bay and into the Atlantic Ocean. But if you take all of these rivers and streams that empty into the Delaware River and the whole area that they encompass, we would call that a watershed. A watershed is an entire area drained by a single river system. So there's a huge watershed, the Delaware watershed, that is drained primarily by the Delaware River, but all these other rivers that flow into the Delaware River are part of that watershed, including us right here, where the Pequest empties into the Delaware. We're part of the Delaware watershed. In fact, I'm an alumnus of Belvedere High School, where the Pequest joins the Delaware, stands the school so dear. I won't sing the rest, but that's the alma mater of Belvedere High School, where the Pequest joins the Delaware, because that's where the town of Belvedere is. So to show this in a picture form, here we have a watershed. We've got a river flowing through an area, and all of the water that flows into that river that is divided by a hill on both sides, this entire area in here is one watershed. Now, if water flows on the outside of the hillside, it flows into a different watershed. But here's another picture from the top, like a bird's eye view of a watershed. Here we've got the main river channel and all of the tributaries that empty into that river channel. But all of the areas surrounded by a higher land, if a raindrop landed here, or if a raindrop landed here, ultimately all of these raindrops would empty out a single point, this river, from this watershed. In fact, our 3D model of our township on the side of the classroom here, you can really see the watershed of the Pequest River very well. So that's it for running water, but we're not done yet. We're going to move on to another example of running water in the frozen form. Frozen. Let it go, let it go, let it flow down the hill, we might say, with ice, ice, baby. Ice is, well, moving ice is called a glacier. And there are Different types of glaciers. Most people, when we think of glaciers, might think of this type of glacier, which is technically called a valley glacier. A valley glacier is found in mountain regions and they carve out the mountains. Here we see a picture showing how over time we start out with a mountain. Glaciers form by annual, repeating, year after year accumulations of snow and ice. Eventually, that snow and ice gets so heavy that it begins to flow downhill. And as it does, it picks up a lot of debris. It erodes the mountains and deposits them where the glacier melts. And there are lots of features here that are carved into the mountainside itself from the flowing of ice, frozen water. But another type of glacier that many people don't consider are continental glaciers. Continental glaciers today can be found in places like Greenland, and we're studying the continental glacier there that once extended all the way down to where we live in New Jersey. That's right. During the last ice age, the continental glacier spread all the way down northern half of North America to more southern regions and then stopped and then started to melt. And we are still in a major interglacial period right now. But the Great Lakes, Lake Superior, Lake Michigan, Lake Huron, Lake Erie, Lake Ontario. These lakes were actually formed during the last ice age when the continental glaciers were carving their way through the landscape and then eventually melted. And that meltwater filled in those holes carved out by the glacier into these 5 great lakes. In fact, these are some of the world's major resources of fresh water. These are freshwater lakes originally filled by the melting glaciers 9,000-10,000 years ago. But as that ice melted, after carving its way over the landscape, it created different features. Different features that are some of your vocabulary terms, like moraines and kettles, kames and drumlins, and erratics, which aren't even on here. But we're just going to talk about a couple of them right now. Moraine. A moraine, not a moron, but a moraine is a line of debris. This line of debris here is called the terminal moraine. In fact, we live on top of the terminal moraine right here. That's why there are so many sand and gravel pits in our township. They are mining the line of debris that was left over by the last ice age. The last ice age ended right here, literally right here, and left behind the terminal moraine, which is still being mined today for sand and gravel. Kettles. Kettles are depressions from melted ice that are deep enough to be below the water table. They create ponds. If you drive around Warren County here where we live, you'll see lots and lots of ponds, typically in farmland. Many of those are old kettle ponds that formed during the last ice age. In fact, one famous kettle pond, as it dried out, had one of the world's most famous mastodons uncovered from it right here in Warren County. It's now on display in the Cambridge Museum of Comparative Anatomy, which is up in Harvard, Massachusetts. But several mastodons were uncovered right down the street along Route 46 in a kettle lake because they used to live here. Another feature is called a kame. Kames are mounds of debris, little hills. There's a place not far from us called Island Speedway where you can legally go drag racing. And in that flat plain, which was an ancient glacial lake, it's all dried out now, There are a couple features called islands. They're actually cames, mounds of debris left by the last ice age. Here's a cool one: erratics. Erratics are boulders that were dropped out of the melting ice and left in very unusual places, like on the tops of mountains where these things didn't belong. Uh, the native people, the Lenape, had a different name for them. I can't think of the name offhand. It's a Lenape name, but they believe that these rocks dropped out of the sky because it is so obvious, even to the ancient people that lived here, that these rocks just don't belong here. They came from far, far away. The ancients believed they fell out of the sky. Today, we believe that they fell out of the ice as the ice was melting. There's some really cool erratics right up on the top of Jenny Jump Mountain. There's some cool sandstone erratics that are like these gigantic multi-ton boulders that look nothing like the rocks around them. And it's because they aren't anything like them. They came from about 20 miles to the north and were carried down by the glaciers. Any hikes, actually, just driving down the street, just drive up Route 519 in our township, and you'll see some glacial erratics in people's front yards. Rocks that are out of place. And it's because, well, they are out of place. So the ice age, our last ice age in the continental glacier, certainly had a major impact on our local environment as far as other environments across the country. So lots of different features forming from the continental glacier. That brings us finally to number 5, waves. Waves, perhaps a little bit more straightforward and obvious. Waves from the oceans result in coastal erosion due to various things, including longshore drift, waves from storms, the currents up and down the coast, but primarily the waves can create devastating effects along the coast. Here in New Jersey, we experienced major erosion a number of years ago from Superstorm Sandy, which basically eliminated a number of the beach on the Jersey Shore that we have spent millions of dollars depositing sand and building jetties, features extending out into the ocean to minimize further erosion from the waves. But you can have smaller waves eroding on lake shores and also on larger rivers like the Delaware River. There are waves every time a boat goes by. There are little waves that wash on shore and do a little bit of eroding themselves. So there we have it, our 5 major agents of erosion. And tomorrow, we're going to be doing a little lab activity playing around with these agents of erosion to do some activities with our really cool stream tables set up in the back of the lab. So until then, I'll just say bye-bye.